Hey guys, Mr. McKinney here, just picking up with video 2 for our 10.2 video series on the disk method. So on this video, we're going to jump straight into the whiteboards and practice what we did in the previous video. So go ahead and hit pause and make sure you can do that. Let's see how we did. So we always want to graph it first. So it's a parabola, y-intercept of +9 facing down. You can solve for the intercepts by setting your function equal to 0. You can get that -3 and +3 or where it hits the axis. That's going to tell me what A and B are for when I'm rotating. So we're going from -3 to +3. The R of x is f of x minus the axis of rotation. So -x² + 9 minus the axis of rotation is y = 0. So that's where the -0 comes from. At this point, we can plug it into a calculator and spit out our decimal answer. But we should be practicing our simplifying without a calculator. So that's what the rest of these steps are doing. Integrating, excuse me, multiplying it out first, then integrating, and then substituting. So check your work. And now let's move on to what if we're not rotating around the x-axis. So we want to find the volume of the region bounded by 2 minus x² and the line like y = 1, rotated around the line y = 1. All right, so we always want to start with a picture on this type of problem. So f of x equals 2 minus x² means that I would be starting at +2. It'd be a parabola facing down. The line y = 1. So I'm bounded by this graph and the line y = 1. So this is the region we're looking at. And then we're rotating it around the line y = 1. And the reason this is a disk problem is because we're rotating it around a line that is also the boundary for our region. Which means that the region is going to be touching that line everywhere. So this region has to be touching the axis of rotation in order for it to be a disk problem, which this one is. This is a disk problem. The problem doesn't tell me what A and B are, so I'm going to need to figure that out. And I'm going to figure that out by taking my function and setting it equal to 1. So I'm going to say 2 minus x² is equal to 1. Add the x² over, subtract the 1, so x² = 1. So x would be positive or -1. A lot of times the numbers are going to work out fairly well because setting it up is the hard part. They don't want you to get bogged down in the actual calculations. Okay, so we're doing a disk method. So we're adding up a bunch of circles. So pi r of x squared dx. We figured out that we were going from -1 to +1, and we can pull our pi out. So pi times the integral from -1 to +1. The radius is always my function minus the axis of rotation. Now, we didn't really need to worry about the axis of rotation before because it was y = 0. But here we do need to worry about it. So my function is 2 minus x², and my axis of rotation is -1. Well, the axis of rotation is 1, but I'm doing f of x minus the axis of rotation to get my r of x. Now remember that that whole thing needs to be squared, so we need to simplify it before we try to start integrating everything. Okay, so let's simplify and multiply it out. So integral from -1 to 1. 2 minus x² minus 1. I don't really need these parentheses because nothing's happening, no squared or anything like that. 2 minus 1 is going to be +1. So we're going to get 1 minus x² squared dx. I can't use u sub here. I need to multiply it out because if I was going to use u sub, the derivative here would be -2x dx, and I don't have another x. So we're still simplifying. I haven't integrated yet. If I multiply this out, I'd get 1 minus 2x² plus x to the 4th dx. So now I'm ready to integrate. So integral of 1 is x minus 2x³ over 3 plus x to the 5th over 5. And we're going from -1 to +1. I'm going to switch colors and move up here to simplify. So now we've got pi times, let's plug in positive 1 first. So 1 minus 2 times 1 cubed over 3 plus 1 to the 5th over 5 minus, and then everything with a negative 1. So negative 1 minus 2 times negative 1 to the 3rd over 3 plus negative 1 to the 5th over 5. Now I have to plug in 1 and negative 1 before I can stop. So if this was a non-calculator question, I could now stop at this point. I would keep simplifying to practice. So 1 minus 2/3 plus a 5th, and then this is going to end up being 1. This is going to end up 4 negatives would be positive, but then it's going to be a negative. And if I simplify all this, I would get 16 over 15 pi. And if we type it into our calculator, back at the step when we're allowed to, which would be here if we were on the calculator portion, it should spit out 3.351. Just in case you want to see how to get to 16/15 without a calculator, I did the calculations up here. So this is the first step after you multiply everything out, then start simplifying common denominator of 15. So that's how you would get to this without a calculator. You're going to need a calculator to get to the decimal equivalent. Again, you should be practicing these with and without a calculator. It's definitely fair game on either piece of the AP exam. All right, so why don't you guys try a whiteboard problem when we're rotating about something other than the X or Y axis. All right, let's see how you guys did. And I should have mentioned beforehand, you can use a calculator on this one. The most important part is getting it set up. It's good to practice, but moving forward, we'll probably switch to the calculator for most of these problems. So draw your picture first. We've got sine, and we're bounding it by this horizontal line. Luckily, that's also the line we're rotating around. And that's a common type of thing to see, that one of your boundary lines is also going to be your axis of rotation. Now, it gave us an interval, which turns out to be where they intersect. Because it's where they intersect, that's what allows us to use the disk method on this one, because that ensures that my region is always touching the axis that we're rotating around. Actually, I guess we could have cut it off a little bit closer, but as long as we didn't go past those two endpoints. So, and the reason they had to give us an interval, even though we were bounded by those, was because sine is a repeating function. So this way we know that we're dealing with the first instance of when sine is bounded by this. Otherwise, it's just going to keep repeating every 2 pi. Make sure that you have your function minus your axis of rotation before you square it. So your radius needs to be sine minus √3/2. And again, this one gets really ugly, so I apologize for not saying that you could use a calculator. As long as you got it set up right, that's the most important piece. Rather than trying to cram the rest of it into this video, I'm going to go ahead and cut this one off here, and then hopefully I'll be able to get the rest of this video series into the last video. Hope this is helpful.